If you solve this much question, it is enough. Good morning. Today, we are going to start the equilibrium lesson, which is a part of statics. Okay. Before this, we have studied the resultant of the coplanar force system. Here, now you have to study the equilibrium of the coplanar force system. The objective of this lesson is, after studying this lesson, it is expected that the student should know how to find out the different type of support reactions by using the condition of equilibrium. Okay, what is equilibrium? And how to find out the support reactions for different type of support by using the conditions of equilibrium. Okay. Then the first thing is that what is in the equilibrium? How can you define the equilibrium? Now remember, before explaining you the equilibrium, let me tell you first what is the resultant. Actually, we have finished this lesson. Resultant of the coplanar force system, and this is the equilibrium of the coplanar force system. Clear? Till we are dealing with coplanar force system only. Okay. Now, what is the resultant? So, resultant of a particular force system is a single equivalent force which produces the same effect as that number of forces producing on the body. Now, since resultant is a single equivalent force, means it is a single force acting on the body, and whenever a single force acts, it is always an unbalanced force. And because of this unbalanced force, here there may be the translational motion in the body as well as rotational motion. Here, for calculating the resultant, we used to calculate the value of summation of Fx, summation of Fy, and summation of moment. Here, and we used to get some values for this. Yeah. Now, if suppose summation of Fx is equal to 100 Newton, it means that this is the unbalanced component of the force along x direction. If summation of Fy equal to 200 Newton, means this is the unbalanced component of the force in y direction. Means there is an unbalanced x component, there is an unbalanced y component, means there is an unbalanced force present in the system. And suppose this moment of all the forces together at any particular point is suppose 300 Newton meter. So this unbalanced moment is present in the system. So whenever there is a resultant here, so resultant is an unbalanced force here, and because of that unbalanced force, there may be the translational motion as well as rotational motion, because there is an unbalanced moment also. This unbalanced moment is responsible for the rotational motion, and unbalanced force is responsible for the translational motion in case of a resultant or in case of an unbalanced force. Here, remember one thing. Now, what is meant by equilibrium? Okay. For example, suppose this is one body, let it is A, B, C, D, and some forces are acting on this body. Let it is F1, F2, F3, and F4. Okay. Now, how can you define the equilibrium? So, under the action of this force system, here in a very broad sense, I am going to define the equilibrium. Here, under the action of certain force system, if this body is in the state of rest, if the body is in the state of rest, or even if under the action of certain force system, if the body move with a uniform linear motion, then we can say that it is in equilibrium. Okay. So what is equilibrium? Under the action of certain force system, if the body is in the complete state of rest, or even if under the action of this force system, if the body moves with a uniform linear velocity, then also we can say that it is in equilibrium. Okay. So initially, just you have to remember that here the equilibrium means it is a state of rest. I am coming back to this point, but later. Yeah. So when a body is in state of rest, we can say that it is in equilibrium. Understood? Here. Now, for the body to be in the complete state of rest, here it must satisfy certain conditions. Now, which are those conditions that it must satisfy for the system to be in the complete state of rest or the equilibrium? Here, so remember, for the complete state of rest or for the equilibrium, here there should not be any translational motion, there should not be any rotational motion. ये भी नहीं चाहिए, ये भी नहीं चाहिए. Here, for the body to be in complete equilibrium, there should not be any translational motion, there should not be any rotational motion. If any body satisfies this condition, here if there is no any translational motion, neither there is any rotational motion, we can say that it is in the state of rest, or we can say that it is in equilibrium. Understood? Now, just now I told you that here for the translational motion, the unbalanced force is responsible, and for rotational motion, the unbalanced movement is responsible. Here, so for not to have the translational motion, here that unbalanced force must be equal to 0, and for not to have the rotational motion, the unbalanced movement has to be equal to 0, because this unbalanced movement is responsible for the rotational motion, and unbalanced force is responsible for the translational motion. So for not to have the translational as well as rotational motion for a particular force system, here the unbalanced force must be equal to 0 and unbalanced movement must be equal to 0. Okay, here it means that for complete state of rest, here the force system should be a balanced force system. It must be a balanced force system. There should not be any unbalanced force, there should not be any unbalanced moment to be present in the system. Okay, here, so basically which are the conditions of equilibrium? Here, so under when there is no any translational motion or rotational motion, we can say that it is in equilibrium. So or when there is no any unbalanced force or when there is no any unbalanced moment, we can say that the system is in equilibrium. Or here when any force system is a complete balanced force system, here we can say that it is in equilibrium. Okay. Okay. So when a force system is a balanced force system, we can say that it is in equilibrium. There should not be any unbalanced force, there should not be any unbalanced moment. Here, if any force system satisfies this condition, we can say that it is in equilibrium. So ultimate conclusion is that the equilibrium is nothing but a balanced force system. Here, when a force system is a balanced force system, we can say that it is in equilibrium. Understood? Here, then, now I will ask you the question in other way. Yeah. Now, if any force system is a balanced force system, listen question carefully and try to answer my question. Okay. If any force system is a balanced force system, here what will be the effect of that balanced force system on the body? What will be the effects of the balanced force system on the body? Answer my question.
At rest. It will be at rest.
It will be at rest. Yeah. So the first effect is it will be at rest. It will be at rest. Okay, correct answer. Is there any other effect when a balanced force system is there? Will it create any other effect?
With a constant linear velocity?
Right. Okay. Here under the action, you are absolutely right. Okay. So remember, equilibrium or the balanced force system is not only it should be in the state of rest, but under the action of the balanced force system, the body may remain in the state of rest. Here, or if under the action of this balanced force system, it may move with a uniform linear velocity. Here, so the effect of the balanced force system that it will remain in the state of rest, or here it will move with uniform linear velocity. Okay, so even if the body move with a uniform linear velocity, we can say that it is in equilibrium, because that is the effect of balance force system only. Clear? So don't get confused. Equilibrium is not only it will remain in the state of rest, even if the body move with a uniform linear velocity, not the angular velocity. Angular motion or rotational motion is always accelerated motion. Here, even if it is moving with a uniform speed, here then also there is direction is continuously changing, and that's why it is always accelerated motion. So even if the body is moving with a uniform angular speed, here we can't say that it is in equilibrium. But if it is moving with a uniform linear velocity, we can say that it is in equilibrium. Here, because it is the effect of the balance force system. अगर उसमें unbalanced force रहता है, now how we can say that when the body moves with a uniform linear velocity, it is in the state of equilibrium. How? So remember, when a body moves with a uniform linear velocity, here what will be the resultant acceleration? It will be 0. Yes, and we know that the acceleration is a function of, or it's produced because of the unbalanced force according to the Newton's second law, F equal to ma. This is the unbalanced force because of which this acceleration is producing. And if the acceleration is 0, means the body is moving with a uniform linear velocity, means the acceleration is 0. If the acceleration is 0, unbalanced force is equal to 0. Here, if unbalanced force is equal to 0, we can say that the force system is a balanced force system. Isn't it? Here, so under the action of the balanced force system, the body may move with a uniform linear velocity. Okay, so these are the two effects. It may remain in the state of rest, or it will move with a uniform linear velocity. Clear? So remember, very rarely this question may be asked, but remember, whenever the body moves with a uniform linear velocity, here we can say that it is in equilibrium, and the sum can be solved by applying the conditions of equilibrium. By applying the concept of equilibrium, we can solve that question. But in this lesson, most of the questions we are going to solve here when the body is in the state of rest. Okay. Now, these conditions what I said, here the force system should be a balanced force system, there should not be unbalanced force, there should not be any unbalanced movement. Here, how we can write down these conditions mathematically for the different type of force system? Here, the first, here for concurrent force system. Now, which are the conditions for concurrent force system? Here I am writing the conditions of equilibrium. Conditions of equilibrium. After this, I am going to write it as a COE, conditions of equilibrium. Here now, which are the conditions of equilibrium for concurrent force system? Here, so if any concurrent force system is in equilibrium, here it must satisfy only two conditions of equilibrium. Which are them? Here, summation of Fx should be equal to 0, means there should not be any unbalanced force in x direction, there should not be any unbalanced force in y direction. Okay, so these are the two conditions of equilibrium for the concurrent force system. Or vice versa, here when any concurrent force system is in equilibrium, here it must satisfy these two conditions. For concurrent force system, only two conditions are necessary. Here moment condition is not required for the concurrent force system. Or if any concurrent force system satisfy these two conditions, for any concurrent force system, if the algebraic summation of all forces in x direction and y direction is equal to 0, we can say that it is in equilibrium. Okay, here. Now, for a concurrent force system, since we can apply only two conditions of equilibrium, by using these two conditions of equilibrium, we can formulate the two equations. हम लोग इससे दो इक्वेशंस लिख सकते हैं. And by using that two equations here, we can, by solving these two equations, we can find out the two unknowns. So remember one thing, whenever any concurrent force system is in equilibrium, here by using these two conditions of equilibrium, we can calculate only two unknowns. For a concurrent force system, we cannot calculate more than two unknowns. This thing, I already told you that in resultant also. Even if the sum is of resultant, whenever there is a concurrent force system, for a concurrent force system, we can calculate only two unknowns. We cannot calculate more than two unknowns for the concurrent force system, whether the sum is of resultant or equilibrium. Understood? Any doubt? Okay. Then, for general force system, for general force system. Now, if any general force system, if the body is in equilibrium under the action of some general force system, non-concurrent, non-parallel force system, then this force, for the equilibrium, this force system must satisfy certain conditions. Here, so for a general force system, the rotational motion is also possible. For concurrent force system, rotational motion is never possible because it is a concurrent force system. Under the action of concurrent force system, only linear motion is possible. Rotational motion is not possible under the action of concurrent force system, and that's why this third condition is not applicable over here. But for general force system, since there is a distances also, so because of that, there may be some unbalanced moment. So for this force system to be in equilibrium, along with that unbalanced force, the unbalanced moment must be equal to 0. So which are the conditions of equilibrium for general force system? So for general force system, here one must have to satisfy the three conditions, which are them. The first one is the algebraic summation of all forces along x direction should be equal to 0. Algebraic summation of all forces along y direction must be equal to 0. And algebraic summation of the moment of all forces, if this system is in equilibrium, then the algebraic summation of the moment of all these forces about any point has to be equal to 0. Here, if the summation of fx is equal to 0, summation of fy equal to 0, and summation of moment equal to 0, we can say that the system is in equilibrium. Okay. Here, so for general force system, this force system to be in equilibrium, it must satisfy these three conditions. And by using these three conditions, here we can formulate, we can write the three equations, and by using three equations, we can find out the three unknowns. So for general force system which is in equilibrium, by applying the three conditions of equilibrium for any particular force system, here we can calculate the three unknowns. Okay. Then next important thing, here आपने कभी ऑब्जर्व किया होगा इन केस ऑफ द रिजल्टेंट, अगर जनरल फोर्स सिस्टम का अगर मैं रिजल्टेंट कैलकुलेट करता हूं, रिजल्ट एंड रिमेंबर रिजल्टेंट इज अ अनबैलेंस फोर्स, अगर कोई जनरल फोर्स सिस्टम का अगर मैं रिजल्टेंट कैलकुलेट करता हूं, क्लियर, देन द in that case the algebraic summation of the moment of all the forces, जब रिजल्टेंट प्रेजेंट है तब, here when a system is in equilibrium, here then the resultant force has to be equal to 0, resultant force 0 ही आएगा उसका. लेकिन अगर रिजल्टेंट प्रेजेंट है तो अल्जेब्रिक समेशन ऑफ द मोमेंट ऑफ ऑल फोर्सेस हियर अबाउट एनी पॉइंट इन दैट प्लेन हियर विल बी डिफरेंट, ये सेम नहीं आएगा. अल्जेब्रिक समेशन ऑफ द मोमेंट ऑफ ऑल द फोर्सेस अबाउट ए बी सी डी विल बी डिफरेंट इफ देयर इज अ अनबैलेंस फोर्स. But if the force system is a balanced force system, if the resultant force equal to 0, then algebraic summation of the moment of all these forces about any point, you can select any point as a moment center. Here, algebraic summation of the moment of all forces about any point must be equal to 0. ये 0 ही आएगा. About A ले लो या B ले लो, because it is a balanced force system. Here, resultant के लिए अलग-अलग value आएगा. So, algebraic summation of the moment का. But for equilibrium, the algebraic summation of the moment of all forces must be equal to 0. Okay, so while solving this term, here while using this moment equation, you are free to take the moment about any point, आपका आंसर आ जाएगा. Here, but in case of the resultant, here which point need to be selected as a moment center? Moment center कैसे select कर देगा? Unmute yourself and tell me.
जिसका मिनिमम डिस्टेंस सारे फोर्सेस से सबसे मिनिमम हो, डिस्टेंस शुड बी मिनिमम एंड नोन.
नहीं, my question is in case of a resultant में आप लोग मोमेंट निकालते हैं ना by applying the Varadkar theorem, algebraic summation of the moment about point A. तो ये जो A point है, यार ये A point आप कैसे सिलेक्ट करते हैं? How do you select this point A? मोमेंट
जिसका डिस्टेंस पता हो सारे फोर्सेस से,
जिसका डिस्टेंस पता है वो सारे फोर्सेस से. Anybody else? Okay, listen, in case of a resultant, here you have to select the moment center at that point from which you have to find out the distance of the resultant. Here we equate it with R into D, Varadkar theorem. Here, so in that case, this B is the perpendicular distance of the resultant from this point A. अगर आपको B से perpendicular distance calculate करने का है, या तो B से X intercept calculate करने का है, या तो Y intercept calculate करने का है, तो you are supposed to take the moment about point B. Understood? क्लियर। सो रिजल्टेंट में जो भी पॉइंट से आपको डिस्टेंस कैलकुलेट करने का है, यू आर सपोज टू टेक द मोमेंट अबाउट दैट पॉइंट यू आर सपोज टू सिलेक्ट एज अ मोमेंट सेंटर, बट दैट इज नॉट द केस इन जनरल फोर्सेस, sorry, in case of equilibrium. In case of equilibrium, if all the force systems or all the forces are the balance forces or all the forces are in equilibrium, then the algebraic summation of the moment of all the forces about any point equal to 0. So you can select the moment center any point. You will get the answer. Calculation sometimes if you select the wrong moment center, calculation थोड़ा difficult हो सकता है, but wrong नहीं होगा. Understood? Clear? ये दोनों में difference समझ में आया क्या? Yes, so in case of equilibrium, you can select the moment center anywhere here in that plane. Okay. Then third case is the condition of equilibrium for parallel force system. For parallel force system. Suppose this is one parallel force system, and for this parallel force system to be in equilibrium, here it must satisfy the condition summation of F equal to 0. It may be summation of Fx or summation of Fy. Since here all the forces are in y direction, so for this case it will be summation of Fy equal to 0. If all forces are horizontal, then summation of Fx has to be equal to 0. And second condition is summation of M equal to 0. Because here also, because of the distances, the unbalanced moment may produce. Okay, clear. So again for parallel force system, we can apply only two conditions of equilibrium, and by using these two conditions, we can calculate the two unknowns for the parallel force system. Clear. So these are the different conditions of equilibrium for the different force systems. Here, whenever any force system is in equilibrium, here by using these conditions of equilibrium, we can find out some unknowns. Unknowns may be the forces, maybe the distances, or maybe the angles when the system is in equilibrium. So the major difference between the resultant and equilibrium is that for solving the sum, remember, in case of resultant, we used to calculate the value of summation of Fx, summation of Fy, and summation of M. ये हम लोग calculate करते थे resultant में. Whereas when a system is in equilibrium, we know the value of summation of Fx, summation of Fy, and summation of M. Here, when a system is in equilibrium, then what is the value of summation of Fx, Fy, and summation of M? All has to be equal to 0 when the system is in equilibrium. So, for the equilibrium, by using this as a condition, here we are going to find out some other forces here which are responsible for the equilibrium of that force system. Okay, हम लोग कुछ forces calculate कर सकते हैं here which are responsible for the equilibrium. Okay. Then what is the use of that equilibrium? Here हम लोग ये use करके कौन से type के forces calculate कर सकते हैं, क्या कर सकते हैं? Yeah. So the major or important use of this conditions of equilibrium or this concept of equilibrium is to calculate the support reaction. क्या use है इसका? To calculate the support reaction. To calculate the support reaction. Here one very important thing is use of this equilibrium is to calculate the support reaction. Here now why we need to calculate the support reaction? Here for example if you consider this structure, here this is the column. Okay, here ये structure है और ये इसका horizontal member है, ये beam है. Here और ये beam को support है एक column और यहाँ पे एक दूसरा column है. Understood? Here now how much amount of reactive force exerted by this support or by this column on this structure, this reactive force we have to calculate. Okay, why? Because ये जितना reactive force apply करेगा उतना ही active force ये इस पे apply करेगा. Here और the active force जितना apply करेगा उतना ही ये column reactive force develop करेगा और apply करेगा. According to Newton's third law, active and reactive forces are equal and opposite. Here. So this much is the force exerted on this column, which is equal to R. I've shown this force. This is the active force acting on this, and this is a reactive force exerted by this column. Yeah, so this much force is acting on this column, or this much force is induced in this column, we can say. Yeah. So for designing of this column, इसका जो cross section design करने का है, यार इसमें concrete कितना लगेगा, उसमें रॉड स्टील कितना लगेगा. सेम थिंग हैपेंस फॉर द मैकेनिकल आल्सो. Here, so for mechanical engineering, when any system is in equilibrium, suppose if some mechanism is there, here, and for this mechanism, if you want to design any pin or any key, here, अगर कुछ pin design करने का है, तो considering the equilibrium, आपको पहले calculate करना पड़ेगा कि ये pin पे कितने forces act हो रहे हैं, ये pin पे कितने forces act हो रहे हैं. Here, and by considering that forces, we have to design the dimensions of that pin. Okay, yeah, so this is the use of these conditions of equilibrium. By using these conditions of equilibrium, we can calculate these reactive forces, and that reactive forces are helpful here to design that particular component. Understood? Here, so this designing part is not included in your subject mechanics, neither in second year also. From third year, this designing topic starts. Okay, here, so at that time आपको ये आना चाहिए कि how to calculate the reactive force exerted or acting on that particular component. Okay, here, so here we are going to calculate the support reactions by using the conditions of equilibrium. Now, since we are going to calculate the support reactions by using the conditions of equilibrium, the most important thing is that which are the different type of support here which we use in normal civil and mechanical engineering. Here, and how that support offer the reaction. Here, what is the significance of that support? Here, how it offers the support reaction. Here, if we know that basic concept, then only we can calculate that support reaction. If you don't know how that support offers the reaction, here, how we can calculate that support reaction. Understood? Here, everywhere the support is different depending on the application. Okay. Okay, then before explaining you the support and support reaction, let me tell you what is meant by support. Support and support reaction. Support and support reaction. Throughout the lesson, we have to deal with this different type of support and how that offers the support reaction. Yes. What is the support and support reaction? Yeah. Suppose this is one body. Let's consider one circular body, one spherical body. And the spherical body is in the space. Now, since the spherical body is in the space, here it is free to move in all the direction. ये horizontal direction में भी move हो सकता है अगर कुछ force apply किया तो. If I apply some force, it may move in the y direction also. Here, if I apply the 2-3 forces, here it may rotate also. Means when the body is in the space, here all the three type of motions are available. Here are possible. Here, when the body is in the space, all the three type of motions are possible. Yes, but now for this body, I am keeping it on one horizontal surface. The body is placed now in horizontal surface. Now, what happens because of this surface? Because of this surface, what happens? Yeah, this vertical motion of this body is restricted. ये सपोर्ट से सिर्फ वर्टिकल मोशन रेस्ट्रिक्ट हुआ है. टिल बॉडी इज फ्री टू मूव इन हॉरिजॉन्टल डायरेक्शन इफ आई अप्लाई द फोर्स, टिल द बॉडी इज फ्री टू रोटेट हियर, बट बिकॉज ऑफ दिस सरफेस ओनली वर्टिकल मोशन इज रेस्ट्रिक्टेड. Here, if I apply if I use some vertical surface, then because of this vertical surface, its horizontal motion is restricted. Here, so this constraint to the motion here is known as a support. Support क्या करता है? Support motion restrict करता है. Here, support restrict the motion in a particular direction. Okay, so when a motion of a body is restricted in a particular direction, here that constraint or that restriction to the motion is known as a support, and the reactive force exerted by the support is known as a support reaction. Support reaction क्या है? It is nothing but a reactive force exerted by this support is known as support reaction. लेकिन support क्या है? Support is nothing but restriction to the motion. Here you can restrict the motion by number of ways. मैंने इधर सरफेस ड्रॉ किया, सरफेस ही ड्रॉ करना चाहिए, नॉट नेसेसरी. यार अगर इसका मुझे वर्टिकल मोशन रेस्ट्रिक्ट करने का है तो इट नॉट नेसेसरी दैट मुझे सरफेस ही यूज करना चाहिए. यार आई कैन हैंग दिस बॉडी विद हेल्प ऑफ सम टेबल, तो भी उसका वर्टिकल मोशन रेस्ट्रिक्ट हो जाएगा. सो दैट विल आल्सो बिकम वन काइंड ऑफ सपोर्ट. यार The restriction to the motion here is known as a support, and reactive force exerted by the support is known as a support reaction. Now I told you that the reactive force exerted by the support is known as a support reaction, but it is not necessary that the reaction, support reaction, is always a force. Support reaction may be a force or it may be a movement also. This will be the reactive force, this will be the reactive moment. अभी reactive force कब generate होगा और reactive moment कब generate होगा? Yeah. So listen, whenever the linear motion of a body is restricted, when linear motion is restricted, reaction shall be a force. Whereas when rotational motion is restricted, reaction shall be a moment. When rotational motion is restricted, reaction shall be a moment. Here, when linear motion is restricted, reaction shall be a force. For example, suppose this is one body, or let's consider again circular body, which is resting on this horizontal surface. अभी इसमें body is free to rotate. Rotational motion restrict नहीं किया है, it is free to rotate. अभी ये restrict नहीं किया है, rotational motion restrict नहीं किया है, तो इसकी वजह से ये support यार reactive moment will not apply. It cannot apply the reactive moment. अगर मैंने इस पे मोमेंट अप्लाई किया तो बॉडी रोटेट हो जाएगा, इट वोंट रिमेन इन इक्विलिब्रियम, क्योंकि ये सपोर्ट वो रिस्ट्रिक्ट नहीं कर सकता है. यार सिमिलरली इफ आई अप्लाई द फोर्स इन दिस डायरेक्शन, द बॉडी विल मूव इन दैट हॉरिजॉन्टल डायरेक्शन, क्योंकि दिस सपोर्ट विल नॉट रिस्ट्रिक्ट दैट मोशन आल्सो. Okay, so when the linear motion is restricted, reaction shall be a force in that direction, and when rotational motion is restricted, reaction shall be a moment. यार अभी इसमें देखो, because of this support, the vertical motion is restricted, and since vertical motion is restricted, here at this point of contact, here reaction shall be a force in vertical direction. जो डायरेक्शन में मोशन रेस्ट्रिक्ट हुआ है, रिएक्शन शैल बी अ फोर्स इन दैट डायरेक्शन. और अगर रोटेशनल मोशन रेस्ट्रिक्ट हुआ है तो रिएक्शन शैल बी अ मूवमेंट. हियर फॉर एग्जांपल सपोज लेट कंसीडर सपोज दिस बॉडी, कंसीडर दिस रॉड. हियर नाउ आई हैव कनेक्टेड दिस रॉड एट दिस एंड हियर टू वन ब्रैकेट. यहाँ पे एक ऐसा ब्रैकेट है, मैंने ये रॉड को यहाँ पे ब्रैकेट से कनेक्ट कर दिया विद हेल्प ऑफ वन पिन जॉइंट. हियर ऐसा रॉड है और ये एंड पे उसको विद हेल्प ऑफ सम ब्रैकेट मैंने विद हेल्प ऑफ पिन जॉइंट उसको कनेक्ट कर दिया है. ये ब्रैकेट फिक्स है, ऐसे एक्सटर्नल सपोर्ट को ब्रैकेट फिक्स है. ओके, लेकिन ये ब्रैकेट को यहाँ पे पिन से ये रॉड कनेक्ट कर दिया. यार यू मस्ट ऑब्जर्व दैट डोर क्लोजर में ऐसा सिचुएशन रहता है, एक ब्रैकेट रहता है वो डोर के फ्रेम को कनेक्टेड रहता है यार, एंड वो ब्रैकेट में एक ऐसा रॉड से कनेक्ट रहता है और ये रॉड ऐसा रोटेट होता है डोर क्लोजर में. यू मस्ट ऑब्जर्व दैट. यार सो इट इज अ पिन जॉइंट. अभी पिन जॉइंट में क्या होता है देखो, बिकॉज ऑफ दिस पिन जॉइंट हियर इट्स वर्टिकल मोशन इज रेस्ट्रिक्टेड. ये पिन उसको वर्टिकली मूव नहीं होने देगा या तो हॉरिजॉन्टली भी मूव नहीं होने देगा, बट एट दिस पिन जॉइंट द रोटेशनल मोशन इज अलाउड. इजंट इट? यार एट दिस पिन जॉइंट द रोटेशनल मोशन इज अलाउड. यार मतलब यहाँ पे अगर मैंने ऐसा पिन जॉइंट यूज किया तो ये रॉड हॉरिजॉन्टल इक्विलिब्रियम में रहेगा क्या? नहीं रहेगा. यहाँ पे पिन जॉइंट होने की वजह से वो नीचे आ जाएगा बिकॉज ऑफ द मूवमेंट प्रोड्यूस बाय द वेट. यार वो नीचे आ जाएगा. इजंट इट? आर यू गेटिंग माय पॉइंट? यार अभी देखो, मुझे ये रोटेशनल मोशन रेस्ट्रिक्ट करने का है. यार यहाँ पे पिन जॉइंट है और मुझे ये रोटेशनल मोशन रेस्ट्रिक्ट करने का है. तो अगर यहाँ पे पिन जॉइंट और मुझे ये रोटेशनल मोशन रेस्ट्रिक्ट करके अगर ये बॉडी को स्टेट ऑफ रेस्ट में अगर लाने का है तो व्हाट आई कैन डू, मैं क्या क्या कर सकता हूँ? आई कैन अप्लाई वन मोर सपोर्ट ऑन एट दिस एंड. ऐसा एक सपोर्ट मैं दे सकता हूँ तो इक्विलिब्रियम में रहेगा. नहीं तो ऊपर से मैं एक केबल से उसको लटका सकता हूँ. यार I can hang it with one cable, then also it will remain in equilibrium. But without any applying any support on this end, यार मुझे उसका रोटेशनल मोशन रेस्ट्रिक्ट करने का है. तो क्या करना पड़ेगा? So to restrict the rotational motion without applying the force at this other end, here at this end what I will do, I will apply such type of moment. ये देखो यहाँ पे ऐसे moment अप्लाई करूंगा. अभी now I am applying the moment. See my finger. This finger is applying the force downward, and this finger applying the force upward. Okay, clear? And because of these two forces, clear, one reactive moment is generated. क्या किया मैंने यहाँ पे ये रॉड को, यार ये जो वेट की वजह से जो मोमेंट जनरेट हो रहा था उसको मैंने बैलेंस किया. लेकिन उसको कैसे बैलेंस किया मैंने ये सपोर्ट पे उसको यार दो इक्वल अपोजिट एंड पैरेलल फोर्सेस अप्लाई किए, सॉरी ये रॉन्ग हो गया, ऐसे दो इक्वल अपोजिट एंड पैरेलल फोर्सेस अप्लाई किए, तो दिस टू इक्वल अपोजिट एंड पैरेलल फोर्सेस प्रोड्यूस द couple, and that movement of this couple balance the movement of this force, and because of that there won't be any rotational motion. Okay, yeah, so this is the reactive moment. ये क्या बन गया यार, this is the reactive moment. यार तो reactive movement कब generate होता है? When rotational motion is restricted, reactive moment is generated. When linear motion is restricted, here reactive force is generated. Here, have you understood this concept? Yeah, so remember one thing, reaction is not only a force, here reaction may be a moment also. So reactive moment कब generate होगा? When rotational motion is restricted, reaction shall be a moment. Any doubt?
सर
हाँ
हेलो,
बोलो।
अगर हम लोग ने रिएक्टिव मोमेंट लगाया है लेकिन वो रिस्ट्रिक्ट नहीं किया है तो हॉरिजॉन्टल ये सब मोमेंट होगा क्या उसका?
हॉरिजॉन्टली मोशन होगा क्या?
हाँ वही मोशन।
हो सकता है यार। तो फॉर द कंप्लीट इक्विलिब्रियम आपको तीनों टाइप का मोशन रेस्ट्रिक्ट करने का है, या तो अगर ये बीम को मुझे अगर तीनों टाइप का मोशन अगर रेस्ट्रिक्ट करने का है, या तो मुझे ऐसा सपोर्ट यूज करना पड़ेगा जो उसको हॉरिजॉन्टल भी मूव नहीं होने देगा, वर्टिकली भी मूव नहीं होने देगा और रोटेट भी नहीं होने देगा, उसको अगर कंप्लीट इक्विलिब्रियम में रखने का है तो फिर मैं क्या करूंगा इस केस में यार, यहाँ पे मैं एक फिक्स सपोर्ट यूज करूंगा। मतलब ये जो रॉड है, ये जो सपोर्ट से मुझे फिक्स करने का है, मैं क्या करूंगा, ये रॉड को वो सपोर्ट से वेल्डिंग कर दूंगा। अगर वेल्डिंग कर दिया इसको तो इट बिकम अ परमानेंट फिक्स टाइप ऑफ सपोर्ट। यार ये रॉड को अगर इसको वेल्डिंग कर दिया, वेल्डिंग, रिवेटिंग, बोल्टिंग या कॉन्क्रीटिंग, यार ऐसा अगर इसको कॉन्क्रीटिंग कर दिया, इसके साथ रिवेटिंग कर दिया, तो क्या होगा यार, अगर ये फिक्स कर दिया इधर, ना तो ये हॉरिजॉन्टल डायरेक्शन में मूव करेगा, ना तो वर्टिकल डायरेक्शन में मूव करेगा, ना तो रोटेट होगा। यार ये सपोर्ट की वजह से तीनों टाइप के मोशन रेस्ट्रिक्ट होते हैं। अंडरस्टूड? हम लोगों को वही स्टडी करने का है कि विच आर द डिफरेंट टाइप ऑफ सपोर्ट एंड हाउ दैट सपोर्ट ऑफर द रिएक्शन। यार आफ्टर स्टडिंग दिस लेसन आपको इतना तो भी समझ में आना चाहिए कि मुझे ये मोशन रेस्ट्रिक्ट करने का है तो मुझे कैसे टाइप का सपोर्ट लगेगा। अंडरस्टूड? यार लिसन टू मी, फॉर एग्जांपल सपोज आपने देखा होगा स्लाइडिंग डोर रहता है। स्लाइडिंग डोर तो देखा होगा आपने कभी, है ऑब्जर्व द स्लाइडिंग डोर। ये एप्लीकेशन समझ में आया क्या आपको? हैव अंडरस्टूड दिस एप्लीकेशन?
यस सर।
ओके, नाउ आई विल गिव यू अनदर एग्जांपल। सपोज स्लाइडिंग डोर देखा है, स्लाइडिंग डोर, घर में स्लाइडिंग डोर रहता है। ओके, स्लाइडिंग डोर का मैकेनिज्म कैसा रहता है? एक उसमें या तो बॉटम पे, मोस्टली बॉटम पे तो नहीं रहता है, लेकिन टॉप पे ऐसा एक चैनल रहता है। ओके, ये डोर है, ये डोर है। ओके क्लियर? एंड विद हेल्प ऑफ सम नट एंड बोल्ट, यार ये चैनल पे ऐसे रोलर रहते हैं। ओके, एंड दैट रोलर रोल ऑन दैट चैनल एंड बिकॉज ऑफ दैट द डोर कैन बी स्लाइड। यार कभी देखा है ऐसा डोर, स्लाइडिंग डोर?
यस सर।
ओके, तो अभी दिस आर आल्सो द सपोर्ट टू दिस डोर। ये डोर को सपोर्ट है, या दीज आर द सपोर्ट टू दिस डोर। लेकिन ये सपोर्ट पे क्या हो रहा है देखो अभी, यार बिकॉज ऑफ दिस रोलर दिस बॉडी इज फ्री टू मूव इन हॉरिजॉन्टल डायरेक्शन। हॉरिजॉन्टल मोशन रेस्ट्रिक्ट किया क्या? नहीं किया। सिंस द हॉरिजॉन्टल मोशन इज नॉट रेस्ट्रिक्टेड, यार हॉरिजॉन्टल डायरेक्शन में रिएक्टिव फोर्स जनरेट नहीं होगा। अगर मैं ये डोर पे हॉरिजॉन्टल फोर्स अप्लाई करता हूं तो ये रिएक्टिव फोर्स नहीं जनरेट होगा यार, एंड बिकॉज ऑफ दैट द डोर विल मूव इन द डायरेक्शन ऑफ द अप्लाइड फोर्स। ओके, या तो ये रोलर की वजह से हॉरिजॉन्टल मोशन रेस्ट्रिक्ट नहीं होगा, इट विल बी अलाउड here, but because of this roller and because of this channel here its vertical motion is restricted। उसका vertical motion restrict हुआ है। Here as well as here this construction is such that its rotational motion may be allowed, may not be allowed। if it is allowed, ऐसा हो सकता है अगर ये डोर में ऐसे खींचता हूं तो ये इधर रोटेट भी हो सकता है। This rotational motion is also not restricted here। So first type of support is known as a roller support। इसको क्या बोलते हैं? roller support। Understood? Here on the other hand, let's consider a normal door। जो अपने घर का डोर रहता है, ये नॉर्मल डोर। ओके, नॉर्मल डोर को सपोर्ट किधर रहता है? कैन यू टेल मी? नॉर्मल डोर को किधर सपोर्ट रहता है?
hinges.
हाँ, एक साइड में इधर हिंजेस रहता है, isn't it? ऐसे 2 या 3 हिंजेस रहेंगे, अंडरस्टूड? हियर एंड दैट हिंजेस आर फिक्स टू द वॉल या डोर के फ्रेम को सपोर्ट फिक्स रहता है। हियर दिस बॉडी इज द डोर विच इज अंडर कंसिडरेशन। हियर तो अभी इधर क्या होता है ये हिंजेस की वजह से? हियर सो एट दिस हिंजेस, हियर दिस डोर इज फ्री टू रोटेट होगा। रोटेशनल मोशन रेस्ट्रिक्ट हुआ है क्या? नहीं हुआ है। दैट्स व्हाई ये सपोर्ट पे मूवमेंट रिएक्टिव मूवमेंट जनरेट नहीं होगा। रिएक्टिव मूवमेंट तभी जनरेट होता है व्हेन देयर इज अ रोटेशनल मोशन इज रेस्ट्रिक्टेड। यस, यहाँ पे रोटेशनल मोशन अलाउड है। नाउ सिंस द रोटेशनल मोशन इज अलाउड, द रिएक्टिव फोर्स विल नॉट जनरेट एट द टाइप ऑफ सपोर्ट। ओके, क्लियर? And because of this hinges क्या हो रहा है इधर? This door is not free to move in vertical direction. डोर हम लोग वर्टिकल डायरेक्शन में मूव कर सकते हैं क्या? नहीं कर सकते। और नॉर्मल डोर हॉरिजॉन्टल डायरेक्शन में मूव कर सकते हैं क्या? ऐसे मूव कर सकते हैं क्या? नहीं, बिकॉज इट इज कनेक्टेड टू दिस hinges or pin, and that hinges is connected to the support, to the wall, to the frame. Here, and because of that, horizontal motion as well as vertical motion, both type of motions are restricted. Yeah, so at this support, yeah, since horizontal motion is restricted, reaction shall be a force in horizontal direction. And since vertical motion is also restricted, reaction shall be a force in vertical direction. Okay, जो डायरेक्शन में मोशन रेस्ट्रिक्ट हुआ है, रिएक्शन शैल बी अ फोर्स इन दैट डायरेक्शन। क्लियर? अगर रोटेशनल मोशन रेस्ट्रिक्ट किया है तो रिएक्शन शैल बी अ मूवमेंट। क्लियर? सो दीज आर द एग्जांपल ऑफ द डिफरेंट टाइप ऑफ सपोर्ट। क्लियर? दिस इज नोन एज अ हिंज सपोर्ट, this is known as a roller support, and this is known as a fixed support. What is the significance of this? यहाँ पे तीनों टाइप के मोशन रेस्ट्रिक्ट हुए हैं। यहाँ पे सिर्फ रोटेशनल मोशन रेस्ट्रिक्ट हुआ है, और यहाँ पे रोटेशनल मोशन एज वेल एज वन डायरेक्शन मोशन इज रेस्ट्रिक्टेड। अदर डायरेक्शन ऑफ मोशन, जो डायरेक्शन में रोलर्स है, वो डायरेक्शन ऑफ मोशन इज अलाउड। Understood? Clear? So these are the different type of support and how that offer the reaction. Here, I'm coming back to that different type of support. Here, today is not possible to go for this different type of support, लेकिन याद रखो ये तीनों। Okay, fixed support क्या है, roller क्या है, और hinge क्या है, इसमें क्या होता है? Here, any doubt? Understood?
Yes, sir. Yes, sir.
Okay. Now today, actually, we have to learn the different type of supports now. You have to study the different type of support. The major or important type of support here from your subject point of view, here are the smooth support, flexible support, fixed support, roller support and hinge support. 5 type of support enough है आपके लिए। ओके, यार लेकिन पांचों के पांचों आज मैं अगर लेता हूं तो आप बोर हो जाएंगे। यार मैंने बेसिक थिंग्स आपको बता दिया कि हिंज में क्या होता है, रोलर में क्या होता है, फिक्स में क्या होता है। Here, but now here today I'm going to explain you the different type of support. Here, if you have the PDF, you can refer that. Here, different type of supports are given. The first type of support is the smooth support. Smooth support, or it is also known as the frictionless support or frictionless support. अभी मैं क्या बोलने वाला हूँ आपको कि ये सपोर्ट कैसे रहता है here, or and how that support offer the reaction depending on the direction, कौन सा मोशन रेस्ट्रिक्ट किया है और क्या रेस्ट्रिक्ट किया है। ओके, यार so you while solving the sum you should know कि ये कौन से टाइप का सपोर्ट है यार, और ये कैसे रिएक्टिव फोर्स ऑफर करेगा यार, वो आपको समझ में आना चाहिए। यार, so the first type of support is the smooth support. Now what is the smooth support? Yeah, for example, suppose this is one body. Let's consider again circular body. Yeah, which is resting on the surface, maybe horizontal, vertical, inclined. Then this body is restricted on a suppose horizontal surface without permanent fixity. यार ये जो ऐसा दिखाते हैं, this is the convention for the fixed support और fixed surface. ये surface fixed है, यार जैसे ये बेंच है, fixed surface है, तो इसको अगर शो करने का है तो this is the convention. Yeah, this is the convention for the fixed surface. Here, अभी ये फिक्स सरफेस पे दिस बॉडी इज जस्ट रेस्टिंग, ये सरफेस फिक्स्ड है, उस पे बॉडी सिर्फ प्लेस किया है यार. दिस बॉडी इज नॉट परमानेंटली फिक्स्ड टू द सरफेस, इट इज जस्ट प्लेस्ड अगेंस्ट दैट सरफेस. Okay, yes, so whenever the body is just resting against any surface without permanent fixity, here then such type of support is known as a smooth support. इसको क्या बोलते हैं? स्मूथ सपोर्ट. क्लियर? अभी यहाँ पे देखो क्या हो रहा है, बॉडी हॉरिजॉन्टली मूव कर सकता है, अगर इधर से फोर्स लगाता हूँ वो उधर चला जाएगा, मतलब हॉरिजॉन्टल, दिस सपोर्ट कैन नॉट रिस्ट्रिक्ट द हॉरिजॉन्टल मोशन. क्लियर? सिमिलरली अगर उस पर अगर आप फोर्स लगाता हूँ टॉप पे, तो इट मे रोटेट ऑल्सो, रोटेशनल मोशन भी ये सरफेस या तो ये सपोर्ट restrict नहीं कर सकता है. But this support restrict the motion in vertical direction. Because of this horizontal surface, its vertical motion is restricted. And since vertical motion is restricted, reaction shall be a force in that direction. Okay. Yeah, so remember here how the smooth support offer the reaction. How the smooth support offer the reaction. So remember one thing, at the smooth support, here how to identify the smooth support, the body is just resting against any plane surface. So that becomes the, or body is just resting against any type of surface, यार without permanent fixity, so that becomes the smooth support. वहाँ पे friction नहीं रहता है. तो वहाँ पे reactive force कैसे generate होगा? तो reactive force always generated at the point of contact. It is normal to the surface. ये surface को normal रहेगा वो. Here and always directed toward the body under consideration. If this is the body under consideration, the reactive force exerted by this surface on the body to hold it in equilibrium must be upward direction. Here, you have to hold this body in equilibrium. ये support में कैसा support reaction apply करना चाहिए? It has to be upward. तो ये equilibrium में रहेगा. Isn't it? यार तो कैसे याद रखने का कि smooth support पे reactive force कैसे apply होता है? So at the smooth support, the reactive force is always directed, always at the point of contact, normal to the surface and always directed toward the body under consideration. Okay, here if this point is A, we can say that this is the reactive, R stands for the reactive force at A. R suffix A, reactive force at A. Understood? Here, so whenever there is a smooth support, हम जब भी solve करेंगे तभी भी जब भी ऐसा support आएगा तो वहाँ पे reaction ऐसा ही रहेगा. And since this reaction is normal to the surface, yeah, this is also known as a normal reaction. ये word सुना होगा आपने. It is known as a normal reaction. Why it is a normal reaction? Because it is perpendicular to that surface. It is normal to that surface. Clear? Let's consider another case. Yeah, suppose this is one body which is resting against this surface. Clear? If it is just resting against this surface, it won't remain in equilibrium. Because of the weight, it may fall. Okay, but because of this surface, its horizontal motion is restricted. Here, and because of this surface, since horizontal motion is restricted, here reaction shall be a force at that point of contact. Here, अभी यहाँ पे reactive force कैसे generate होगा? Here, what I said, reactive force always generated at the point of contact, normal to the supporting surface and always directed toward the body under consideration. Here, so this is the reactive force at point A. यहाँ पे reactive force ऐसे आएगा. Understood? And since whenever there is a circular body, since this reactive force is normal to the surface, अगर इसका line of action extend करता हूँ तो it will always pass through the center or centroid. Understood? Clear? Now, for example, suppose for this body, I applied to hold it in equilibrium. ये एक ही support reaction से equilibrium में नहीं रहेगा. ये रह सकता है. ये नहीं रहेगा. Clear? So to hold it in equilibrium, I need to apply one more support. तो मैं एक ऐसा incline support apply करता हूँ. ऐसा एक V surface है और उसमें वो cylinder रखा हुआ है. So it will remain in equilibrium, isn't it? Clear? Okay. So since this body is in contact with this surface, inclined surface, which is inclined at angle of theta degree at this point B, या तो यहाँ पे एक reactive force generate होगा, isn't it? Which will be normal to this surface, perpendicular to this surface. इसका line of action extend किया तो वो भी center में से pass होगा. Clear? Now since this is the reactive force at point B, let's denote it as a RB. Clear? It is perpendicular to this surface. Now if this angle is theta and this line of action is perpendicular to this surface, this angle is 90 degree, so this angle becomes 90 minus theta, which is required for while solving the sum. Okay, here so at the smooth support, the reaction is always normal to the supporting surface and directed towards the body under consideration. Yeah. So remember one thing, at the smooth support, the reactive force always induced at the points of contact, normal to the supporting surface, and always directed towards the body under consideration. It is always directed towards the body under consideration. Clear? याद रखो. Whenever we will solve the sum, और अगर ऐसा पूछते हैं कि फाइंड आउट द रिएक्टिव फोर्स एट पॉइंट ए, तो आपको दिखाते आना चाहिए कि वहां का रिएक्टिव फोर्स कैसा रहता है. अंडरस्टूड? यार, एनी डाउट? यार, आई एम कंसीडरिंग वन मोर एग्जांपल. लेट्स कंसीडर द सरफेस इज कर्व. यार, ऐसा एक सरफेस है, कर्व सरफेस है ऐसा, और उस पे एक रॉड रेस्ट्रिक्ट किया हुआ है ऐसा. One rod is resting against this. Now rod will remain in equilibrium. The rod is AB and supported at point B and C. Okay. Now it is just resting against these two surfaces, so it becomes a smooth surface, smooth support. Now how it will offer the reactive force? How that surface offer the reactive force on the rod to hold it in equilibrium in this particular position? Clear? So B पे reactive force कैसे आएगा? Now the supporting surface is horizontal, so यहाँ का reactive force will be the normal to the surface and directed toward the body under consideration. So this will be RB. यार simple है. C पे reactive force कैसे आएगा? अभी यहाँ पे जो supporting surface है वो semi circular है. Okay, I told you that the and this rod is tangential. I told you that the reactive force at the smooth support is normal to the surface. यार यहाँ का reactive force कैसे रहेगा? Normal रहेगा. This is normal रहेगा. ये रॉड टेंजेंशियल है और ये रिएक्टिव फोर्स नॉर्मल रहता है. मतलब ये लाइन ऑफ एक्शन ऑफ दिस आरसी विल बी परपेंडिकुलर टू द रॉड बिकॉज इट इज नॉर्मल. एंड सिंस इट इज नॉर्मल, अगर इसका लाइन ऑफ एक्शन एक्सटेंड करता हूं तो इट विल पासिंग थ्रू द सेंटर ऑफ दिस सेमी सर्कल बिकॉज इट इज नॉर्मल. यार ये सब ज्योमेट्री आपको आना चाहिए. यार इक्विलिब्रियम में इतना ज्यादा कंसेप्ट नहीं है यार, बट मोस्ट ऑफ द टाइम द स्टूडेंट फाइंड डिफिकल्टी इन ज्योमेट्री. Okay, so this is all about the smooth support. Now at the smooth support, here at any support, if you consider, here we know the direction of this reactive force. This reaction is a force. For its complete specification, we require its magnitude and direction. यहाँ पे एक ही force है. At this smooth support, there is only single reactive force. And for this single reactive force, we know the direction of that reactive force. इसका direction हम लोगों को completely पता है. It is normal to the surface and directed toward the body. Direction completely पता है. So unknown thing is only magnitude. Okay. So whenever there is a smooth support, there is only one unknown. Smooth support पे कितने unknowns रहते हैं? एक smooth support पे सिर्फ एक unknown रहता है, and that is the magnitude of reaction. Clear? आपको ये number of unknowns भी count करके आना चाहिए. Clear? For example, suppose अभी ये body है, इसका weight है 500 Newton. And if it is asked to calculate because of this 500 Newton, here calculate how much is the reactive force generated at points A and B. Okay, या तो इसका अगर मैं simplified figure draw करता हूं तो this is 500 Newton, यहाँ का एक reaction RA आएगा, इधर का एक reaction RB आएगा. मतलब ये force system में which become the constant force system which is in equilibrium, for which we can apply the two conditions of equilibrium, and by using the two conditions, how many unknowns I can calculate? I can calculate only two unknowns. Clear? Now in this force system, how many unknowns are there? In this force system, there are only two unknowns. Which are the two unknowns? Magnitude of RA and RB. And by using the two conditions, I can get that two unknowns. यार तो आपको पहले ही पता चल जाएगा कि ये सब मैं सॉल्व कर सकता हूँ या नहीं. यार how many number of unknowns are there? How many conditions equilibrium I can apply? Okay, तो इसके लिए आपको number of unknowns भी count करके आना चाहिए. Yes, so at the smooth support, how many unknowns are there? At the smooth support, there is only one unknown, and that is the magnitude of that reaction. Understood? Yeah. So this is all about the smooth support. The second type of support is, which we have to study, is the flexible support. Flexible support. Now, what is the flexible support? The flexible support is nothing but the support given by the flexible thing. Flexible things means like a rope, chain, wire, belt. Here, all these are the flexible things which we can use for giving the support also. Okay, so for this rod at one end, suppose there is a pin joint. So यहाँ पे ये equilibrium में horizontal position में नहीं रहेगा. So I need to apply one more support on this side. Here, so instead of applying the support from the bottom, rigid support from the bottom. Here मैं इसको ऐसे with the help of one cable इसको ऐसे hang भी कर सकता हूँ. Here, so that cable also become one support. Here it is a flexible support. It is known as a flexible support. Support given by the rope, chain, wire. Here, now let's consider this rod. यहाँ पे pin joint है ऐसा. Here, and to hold it in equilibrium, here I apply one wire at point B. This is the wire, and it is hang with some external support. घर पे करते हैं ना हम लोग ऐसा. Here कुछ वो प्लास्टिक का पेपर अगर लगाने का है, here during the rainy season, here so उसको ऐसा with the help of some cable हम लोग उसका बांध देते हैं. Here so this is we attach it to some external support. Here this is the body under consideration. Here अब ये body पे यहाँ पे एक support है, यहाँ पे एक support है. So at this end support कौन सा support है? It is a flexible support. Okay. Now how that flexible support offer the reaction on the body to hold it in equilibrium? Flexible support कैसे reactive force offer करता है? Clear? So remember one thing. Whenever there is a flexible thing, the reactive force exerted by that flexible support on the body is always a tensile force. Because of its flexibility, it can apply only tensile force. It cannot apply the compressive force. With the help of some cable or chain, I can pull the body. मैं body को pull कर सकता हूँ. I cannot push it. मतलब इसमें सिर्फ tensile force generate हो सकता है, इसमें compressive force generate नहीं हो सकता है. And that's why whenever such type of flexible support is there, that flexible support is always in tension. It is the force induced in that flexible support is always a tensile force. Here, so how it offer the reaction? It offer the reaction as a tensile force. And you know that how the tensile force acts. Tensile force कैसे act होता है, किधर act होता है, उसका direction किधर रहता है? Tensile force का
away from body.
It is away from the body. It is a pull type of force. Here, ये reactive force directed toward the body. Whereas जब भी flexible support रहेगा, here उसमें tensile force generated होगा और वो tensile force always acts away from the body under consideration. अभी away from the body is okay, but whether it is horizontal or vertical or whether it is normal to this rod or something like that. So remember one thing, whenever there is a flexible support, the reactive force always acts along the cable. Cable अगर horizontal है तो horizontal, cable अगर vertical है तो vertical, cable अगर incline है तो incline. So at flexible support, the reactive force is always acts along the cable and away from the body under consideration. Clear? So whenever there is a cable, here उसमें जो force generate होगा, here that force is always a tensile force which always acts along the cable and away from the body under consideration. Clear? इस पे force ऐसे act होगा और अगर ये support अगर मैं if I consider take into consideration, so tension induced in this cable but acting on this support here is acting along the cable and away from the body under consideration. Understood? Clear? Listen. This magnitude is remains same. Here only when I consider the FBD of this or simplified figure of this rod, it acts along the cable and away from the rod. When I consider this support, then it acts along the cable and away from this support. Because tensile force always acts away from the body under consideration. Here, ये दोनों forces का magnitude same रहेगा. ये दोनों forces अलग-अलग forces है, same forces नहीं है. These are the two different forces. एक action है तो दूसरा reaction है. Understood? Here, according to the Newton's third law, these action and reactions are equal in magnitude and opposite in direction. Understood? तो जब भी आप केबल कंसीडर करेंगे तो उसमें का जो टेंसाइल फोर्स रहेगा, here that टेंसाइल फोर्स का मैग्नीट्यूड सेम ही रहेगा, चाहे ये बॉडी अंडर कंसीडरेशन में ले लो या ये बॉडी अंडर कंसीडरेशन में ले लो. एंड इट ऑलवेज एक्ट अवे अलोंग द केबल एंड अवे फ्रॉम द बॉडी अंडर कंसीडरेशन. यार ऐसा मत सोचो कि सर इधर अगर ये प्लस आता है तो ये माइनस आएगा, क्या नहीं आएगा. Because Newton's third law, what it states, since these are the action and reaction, here they are equal in magnitude. अगर इधर प्लस थी है तो इधर भी प्लस थी, इधर माइनस थी है तो इधर भी माइनस थी. They are equal in magnitude and opposite in direction. Understood? Yeah. So whenever the flexible support is there, it is always in tension, and the tensile force always acts along the cable and away from the body under consideration. Now for this support, here again we know the direction of this force. So unknown is only one. So flexible support पे भी सिर्फ एक unknown रहता है, which is the magnitude of that reaction. Any doubt? Okay, so these are the two important support at the beginning. Here after we'll solve few questions on this, and after that here we'll study that hinge support, roller support, and the fixed support. Okay, clear? Any doubt? Any doubt?
No, sir.
Okay, now you take the break of 10 minutes. After the 10 minutes, join with a link of equilibrium 2. ये link नहीं. Understood? Okay.